Hi there, this is exercise 1B for further mathematicians. Now, it's a very important lesson as much that today we're going to look at how to multiply two matrices. Interestingly, I've got one at the top here. You can see it says A equals, I usually write them in a curly bracket, but you know, some people put them in square brackets. And B equals 0, 3, 2, 1. And what they're doing is they're trying to time them. And what you'll see is this shows you the process by which they get the answer. The answer for AB, by the way, seems to be 4587. So let's just do that now. Let's times these together. I'm going to write them here. 1, 2, 1, 4. And times them by 0, 3, 2, 1. Notice what I'm going to do. I'm going to take that 1. I'm going to times it by the 0. And then I'm going to add the 2 times by the 2. Effectively, I do the top row by the first column. 1 0 is 0, 2 2s are 4, my answer is 4, and I put that 4 there. Having done that, well, I've done the top row by the first column, I go to the top row by the second column. So it's 1 2 times by the 3 1, and you just do it. 1 times the 3 is 3, plus 2 times the 1 is 2, 3 and 2 makes 5. You can see all these calculations I'm doing up here. The next one, to get this, what is they say is 8, I do the 1 times the 0. So notice I've gone to the second row, but I go back to the first column. 1 times the 0 plus 4 times the 2, that's 8. And then I do the 1 4 by the 3 1. 1 times the 3 plus 4 times the 1, I reckon that's 7, and it is 7. So this process of times in a row by a column is what we're going to do. And if you can always practice this, see if you agree with this 3 12 3 8. So times and divide then, it's reasonable, I think, to expect to be able to do this. And I'm saying, unfortunately, it might be reasonable, but it's actually impossible to divide by a matrix. Now there's ways we can get around that later on. But certainly division in its strictest sense you can't do. But we can times, so let's do a times. I've got another one here. Is it the same one as we had before? No, it's different. So I'm going to do that. I'm going to just show you 2 times the 5 and then 0 times the minus 3. But I suppose there's one thing that should be making you think a bit is how do you know what shape it is that you're going to end up with? So it's important that we look at the dimension of each matrix first of all before we can decide if we're going to multiply them together. So we've done dimensions in our last lecture or last lesson. So look here, it's 2 down by 2 across. So I've written 2 by 2, and this is also 2 down by 2 across. Now, notice the middle two numbers agree. That's good. They must agree. If they don't agree, you can't multiply them. So if the middle two numbers agree, then you can multiply them. And then you look at the outer two numbers to decide what shape it's going to be. Now here, it's a 2 by 2 by 2 by 2. So the 2's agree, and the outer ones are 2's. It's going to be 2 by 2. Look at the blue numbers. They tell you the new shape is going to be 2 by 2. And I reckon it's 10, 12, 8, 7. Let's see if that's true. Let's go through the process. 2 5s are 10, plus nothing times that. Well, nothing times that is going to be 0. So my first number's got to be a 10. 2 times the 6 is 12, plus nothing again, because nothing times anything is. So I reckon 12. Switch down to the bottom row. 1 times the 5 is 5, plus minus 1 times minus 3 is plus 3 when you do a minus times a minus. So it's 5 plus 3 is 8. And 1 times a 6 is 6. Minus 1 times a minus 1 is 7. I reckon 7. 10, 12, 8, 7. It works. Notice then you times the top row by the first column, then the second column, etc. And then the third column if there is one. Then you switch to the second row and do the same thing. If there's a third row, you switch to the third row. So let's go with this one. First of all, let's think of the dimensions again. 3 down, 2 across. Okay. And this one says 2 down, 3 across. Yeah, you can see you've got 2's in the middle. So they match. As long as they match, it doesn't have to be 2's, it could be 1 and 1. As long as they match, you will be able to time them. And it's got a 3 and a 3 on the outside, so it will be 3 by 3. So if it was me, I would now draw a 3 by 3 matrix there. And what numbers go inside it? Well, we do the top row by the first column. So 3 2's are 6, plus 1 1 is 7. 3 5's are 15, plus 1 0, that's 0, so it's 15. 3 noughts, that's 0. 1 3 is 3. 4 2s are 8 plus 0 whatever's. It doesn't matter, it's 8. 4 5s are 20 plus 0 whatever's, so it's 20. Lots of noughts on here. Noughts are great, we like noughts. 4 noughts are 0 plus, oh that is a 0 overall. 2 2s are 4 plus 4 1s are 8. Well, 4 1s are 4, but plus the 4 is 8. 2 5s are 10 plus nothing. 2 noughts are 0, and that makes 12 when I do that. I think they're right. 7 15 3, 8 20 0, 8 10 12. So that's what I agree. So that works. And then the last one, look at this again. It's 2 down 1 across, 2 down 1 across, and it's 1 down 2 across. So those numbers are right. Notice the ones agree, and the answer has got to be a 2 by 2, the blue lines. So it's 2 by 2, so if it was me, I'd be thinking 4 numbers. And this is a silly one really, 1 across, it's really just 1 by 2, there you go. Then I switch to the next column, 1 by 3, really silly this. And then I do 4 by the 2, and 4 by the 3. I highlighted that because that's a weird one, you wouldn't normally get that. And the good thing is you can do these on your calculator, and at some point I want you to be able to do them on your calculator. But for now, I'm just passing that by. And perhaps in lesson, I'll show everyone how to do it on the calculator. 2, 3, 8, 12, 2, 3, 8, 12. So that works as well. Now, I suppose I should tell you about commutivity. Two matrices, A and B, are said to commute if AB equals BA. So notice, that's not obvious, as you might think. So for instance, in maths, 2 times 5 normally is 10. You switch the order, 5 times 2 is 10. So multiplication is said to commute. It is commutative. Now this is an idea you've either seen before or you haven't, but things that are commutative, doesn't matter which order you do them in. Now addition is the same. 2 plus 5 is 7. Switch the order, 5 plus 2 is 7. So addition commutes, it's commutative. But 5 take 2, I'll start with a 2, so I'll do a 2. 2 take 5 is minus 3. But if I switch the order, 5 take 2 is 3. They are not commutative, they are different. And this highlights, division's the same by the way. 2 divided by 5, you do, it's 0.4. And 5 divided by 2 is 2.5. They are not commutative. You don't get the same answer. So it's not as obvious as you think that AB should equal BA. But let's see if this does. Commutative. That's what we're looking at. 1, 0, 0, 1, and times in by 2 minus 3. Now, what am I doing here? This says show that they commute. So I'm actually working out AB. Times that there. Okay. So let's multiply it out. Again, I'm expecting to get 0 times 2, nothing. That times that, minus 3. Switch here. 0 times nothing. 1 times 2 is 2. Okay, noughts are brilliant. I do love them. 1 times 2 is 2, and that will give me nothing. 1 times that is minus 3, and 0 times that is nothing. So I think I get that as an answer. So that's AB equal to that. Now we do BA just by putting them in the opposite order. I'm going to write the B first. 2 minus 3 minus 3 and 2. And I'm times in by A, which is 0, 1, 1, 0. So let's just do it. 2 times 0 is 0, minus 3 times that is minus 3. Oh, that's a good start. We've got the same start. 2 times 1 is 2, then that will give me 0. Top line, perfect. Bottom line, minus 3 times that, 2 times, oh, that gives me 0, but this one gives me 2. Good. This one minus 3, and this one gives me 0. It worked. I have proven that AB equals BA, and therefore they commute. Now it does say here that in most cases this is a very unusual thing to happen. I've proven in this case it works. But this says in most cases it doesn't happen. You would expect AB not to equal BA. So a random choice here, another one here. Let's do it here. We've got, I'm going to do AB again. Let's do AB first of all. It equals 3, 1, 4 minus 1. And I've got to times it by b, which is 2520. So I wonder what that is equal to. 3 times 2 is 6. 1 times 2 is 2. That gives me 8. Switch to the second column. 3 times 5 is 15. 1 times, 0 is 0, so that's 15. 4 times 2 is 8. And this gives me minus 2 when I do the minus 1 times 2, so I think that's 6. And 4 times 5 is 20, and that will also give me a 0 again, so I think that's 20 there. That's AB. Let's do BA. The other way round. 2520 times by 314 minus 1. And what's that give me again? I know it's going to be a 2 by 2. 2 5s are 6 and 5 4s are 20. So that's 26. Oh, I can see it doesn't commute already then. I'll finish it off. 2 1s are 2. That's minus 5. I think it's minus 3. 2 3s are 6. 0 whatever's we can ignore. 2 1s are 2 and 0 whatever's are ignore. So I think that's it. And you can see AB does not equal to BA. Therefore, they do not commute. That's what I want to prove. What have I written? Is that the same answer? 8, 15, 6, 20, 26, minus 3, 60. Perfect answer. So look, that's the end of that. I mean, we in class will practice perhaps use of the calculator a little bit more. There's two different types of calculators. But whatever one we're using, I'll teach you how to use. And in class we'll practice exercise 1b. I think exercise 1b is quite quick and short and easy, but I might be wrong, I can't remember. Let's have a look at it.